Welcome to The Explainer. You know how you can zoom in on a photo on your phone, or how an architect can take a huge skyscraper and shrink it down to a tiny model? Well, there's some really cool and elegant math behind all of that. Today, we're diving into geometric dilations.
We do this kind of thing all the time, right? Pinching to zoom, using a magnifying glass to get a closer look at something. It feels totally intuitive, making things bigger or smaller whenever we want. So, how do we actually describe this mathematically? Well, the answer comes from a powerful and, honestly, a surprisingly simple geometric transformation. Let's get into it. Okay, first things first. We need to get the main idea down. What's the official term for all this resizing that we're talking about? In the world of geometry, this is called a dilation. And to pull it off, you really only need two things. A fixed point to scale everything from, we call that the center, and something called a scale factor that tells you exactly how much to resize. So, how do we actually control whether a shape gets bigger or smaller? Well, it all boils down to a really simple set of rules. The key to everything is that scale factor, which we usually just call K. And here's the deal. If K is any number bigger than 1, your shape is going to grow. That's an enlargement. But if K is a fraction, something between 0 and 1, your shape is going to shrink. That's a reduction. It's just one number, but it controls the whole show. Okay, so that's the theory, but how does this actually look in practice? Let's jump onto a coordinate plane and see how it works with a few points. All right, let's start with this simple blue triangle, ABC. We call this our pre-image. That's just the fancy word for the shape we're starting with before we do anything to it. And here it is, the magic formula. And it is so simple, you're going to love it. To dilate any point, all you have to do is multiply its x and y coordinates by your scale factor k. That's literally it. So let's try it with a scale factor of 2. We want to double the size of our triangle. We just apply that simple rule to each corner. So point A, which is at 2, 1, becomes A prime at 4, 2. B becomes B prime, C becomes C prime. It's just some quick multiplication. And there you have it. The new red triangle is a perfectly scaled up version of the original blue one. Now notice a couple of really cool things here. Its sides are perfectly parallel to the originals, and every single point on this new triangle is now exactly twice as far from the center as it was before. Okay, so far so good, right? It's all been pretty straightforward. But now, let's throw in a little twist. What do you think happens if our scale factor is negative? We know what positive scale factors do. They make things bigger or smaller. But what would a negative one do? Something like, say, -1/2. This is where things get really interesting. A negative scale factor actually does two things at once. First, it resizes the figure just like before, but then it also rotates it 180 degrees around the center point. It's like the shape gets pushed straight through the origin and out the other side. You know, an easy way to picture this is as a two-step process. First, just ignore the negative sign and do the dilation like normal. Then, once you have that new shape, just grab it and give it a half turn around the center. So you might be thinking, okay, cool math, but why does this matter? Well, the truth is, you're using dilations all the time, and you probably don't even realize it. Let's look at a couple real-world examples. Okay, imagine you're making some of these photo stickers. Let's say your original picture has a side that's 4 inches long, but the sticker you want to print needs to have that same side be just 1.1 inches. So, how do you find the scale factor? The rule is always the same. You just divide the new size by the original size. So in this case, that's 1.1 divided by 4, which simplifies to a scale factor of 11/40. Or what about this magnifying glass? The description says it makes an object look 6 times bigger than it actually is. So what's the scale factor here? Well, it's just 6. Okay, so if we know the actual spider is 1.5 centimeters long, how big is it going to look through that magnifying glass? How long is the image we see? Yep, you got it. You just multiply the actual length by the scale factor. So 1.5 centimeters times 6 gives us a magnified spider that looks 9 centimeters long. So, what's the big takeaway from all this? Dilations are basically the hidden rules that govern anything we scale. From a tiny pixel on a screen to a massive architectural blueprint, this simple math is what's resizing our world so perfectly. Now that you know what to look for, you are going to start seeing dilations everywhere you go.
in art, in buildings, and in pretty much all the technology you use every single day. Thanks for joining us on The Explainer.